Hey again everyone, welcome to episode 3 of my dev diary, creating a VR exposure therapy game in Unity for the Oculus Rift. Today, I'm going to be talking you guys through the architecture diagram that I've come up with, touching on why I've made certain choices and what the trade-offs are between different possible approaches. So let's start with a little recap on exactly what we want the system to do. We want to tackle a variety of phobias, and we want each phobia to be in its own game mode in its own isolated Unity scene. We want to start in a level selection area where we pick our game mode, any unlocked level, and then we will jump into that scene and progress through a bunch of levels. Each level has some game mechanic and scoring system, and at the end of each level, the system asks you how anxious you were during that level, using subjective units of distress, or SUDs. We want to be saving all of these SUDs ratings so that we can graph them out somewhere and hopefully show the player a decline in their anxiety response after playing through each level a few times. We want the UI to be interactable with the Oculus Touch controllers, which is something we prototyped last episode. So, when planning out the architecture, one of my key priorities was modularity. As said before, we want to have a bunch of different modes for different phobias, spiders, wasps, flying. I've got a bunch of ideas for a potential public speaking mode. Now, each of these modes will have all of the same core components in common. The UI will pretty much be the same. It may or may not be presented in the scene a little differently, but the code behind it won't change. Loading and saving scores, SUDS data, unlocked levels, all of that code will be the same, regardless of what scene we're actually in. So, what we want to do is design the system in such a way that we only write all of that code once. We build the core of the system to be independent of any particular phobia, and then slot those different modes in without having to change any of the core code. This would also mean we could publish the game with just one mode, and then keep adding new modes without affecting anything else in the system. So this is what I've come up with. This isn't super formal UML, I haven't shown what type each parameter is. Sometimes I use array when it's really going to be a list. I haven't explicitly shown these all to be static, I'm kind of taking that as implied if the class is static. If I had a whole team looking at this, I'd add some more detail and clarity so we'd all be sure we were working towards the same thing. But I'm pretty much a one-man band on this project, so it should be good enough just for me. So a quick refresher on some of the symbols here. Hollow diamond is aggregation, which in this context means, say, home scene manager has a reference to the game manager and can access its methods and properties. Filled in diamond is composition, which is pretty much the same. So say phobia scene manager holds references to a UI manager and 10 level managers. But the difference here is that these two classes will never exist without a phobia scene manager. And these arrows here mean inheritance. So spider scene manager is a kind of phobia scene manager, which means it inherits all its properties and behaviors. Oh, and any class that has an asterisk inherits from Unity's mono behavior. So we'll have methods like start, awake, update, that I haven't explicitly declared on the diagram for each class. Firstly, we have this game manager class. Since it's all static and so not tied to any particular instance, it will keep all of its data between scenes. This will primarily be used to change between scenes and exchange data with the save class. I know the aggregation here isn't super accurate. Technically, each class in the namespace has access to everything in Game Manager since it's all static. It's just to illustrate that it's only these two classes that are intended to be accessing Game Manager. The save class will have an array of unlocked levels, each element of the array corresponding to a game mode. So for example, a value of 5 in element 0 means we've unlocked the first 5 levels of game mode 0, which according to our game mode enumeration is the spider mode. The same principle applies to high scores and ratings. A value of 70 in element 04 in high scores would mean we scored 70 points in level 4 of game mode 0. In ratings, each element is a list, so we can have any number of distress ratings for each level. We start in the home scene where we select our level. The home scene manager talks to the game manager and uses this to get all the save information, which it then passes on to the SUDS graph controller so that it can graph out the changes in the player's distress level. Home Screen Manager will use the save data to populate the level selection menu, and when one of the level buttons is clicked, say Spider Level 1, it will call this Select Level method, which in turn will pass the mode and level we want to play to the Game Manager's Change Scene method. The Game Manager will store the starting level and take us into the spider scene. The Phobia Scene Manager will then be able to access the starting level from the Game Manager, and then it will activate the relevant level. Now, regardless of which actual level we're in, whether it's the spider scene or the wasp scene or whatever, the flow of the system is pretty much the same. There'll always be a current level and methods for completing a level, going to the previous level, resetting the level, etc. This will always involve the same communication with the UI, and in the same way, each level will be largely the same. Each one will have a score, a voiceover, a particular setup for its associated game objects, regardless of whether it's a level 1 or a level 10. So, we have this generalized architecture where each phobia scene manager has a UI manager and 10 level managers. The subclass instance of phobia scene manager will be the manager for the specific scene we're in, for example, the spider scene. And all that has to do is manage stuff that's specific to the scene, but not to any of the levels. This might be, say, having a bird in the scene that flies around outside and lands to hang out on the windowsill occasionally. The spider scene manager will then have the list of level managers it inherits from its parent, and each one of these will be an instance of a class that inherits from level manager. For example, spider level 1 manager. This contains all the behaviors and properties that are specific to spider level 1, but anything that is just a general behavior or property of any level is handled by the level manager. If all that's a little confusing, stick with me and we'll keep walking through the flow of the system. So, we just entered the spider scene. We have our spider scene manager that inherits the start method from phobia scene manager, which will get the starting level from game manager, which in our case was level 1. It will find the game object that level 1 manager is attached to and activate it. This not only activates spider level 1 manager, but it also activates that level's game objects in the scene in their initial configurations, as these will all be children of spider level 1 manager's game object. The score will be set to 0, the voiceover will play, and at the same time, spider scene manager uses its inherited reference to UI manager to call the update info and update score methods to display the level number, the score, and the high score for the current level onto the UI. So, now spider level 1 is activated, so the spider level 1 manager will handle everything that is specific to spider level 1. Now, this would be the kind of level where we're asking the player multiple choice questions. Maybe it's a kind of memory or observation thing, like how many red spiders were in the room, 2, 3, or 4. And because there'll be a few levels that do that, we've got our own questions manager class, so that each level with questions can reuse that code too. When spider level 1 manager activates, so will its questions manager, which will then start asking the player questions. When the player hits one of the buttons to answer, it will trigger its submit answer method, and it will compare the given answer to the correct one and change the player's score, which will be a static variable. By the way, I'm keeping the UI for these questions directly attached to the questions manager, rather than going through the UI manager, because the UI objects for the questions are specific to each instance of questions manager, so it just felt sensible to keep them more tightly coupled. After the player gets through all the questions, they'll be presented a summary of how many they got right, at which point they'll either be able to reset the level or complete it. So the player hits complete, which then calls the complete level method on the UI manager, which then shows the suds input UI, the one that we prototyped last episode with the slider. The player will enter their distress level, which will then trigger the submit suds method, which will call spider scene manager's inherited next level method, passing it the distress value. Next level will then call game manager's update save method, passing it the level we're on, the score achieved, and the suds value. Game manager then passes all of this to the save class along with the current game mode. The save class takes the distress value, adds a date to it, and puts it in a list of suds objects for that level. It will store the score if it's the highest achieved for that level, and it will unlock the next level. The save class will then serialize itself into an actual save file on the player's computer. This, by the way, is the reason the save class isn't static. You can't serialize a static class. Meanwhile, next level will deactivate the current level manager, increment the current level number, and activate the next level manager. And then the cycle continues. Other levels work the same way, except they might use an actual spider rather than questions. This design basically means that when we go to add a new mode for the game, for a different phobia, we actually have to do a minimal amount of programming because all of this stuff on the left, all of the stuff in the blue here is already done for us. And everything we want to add just slots into that. We literally just have to worry about the logic and mechanics of each level and what's ambiently happening in the scene. Now, all this spider stuff It's pretty much just an example of what it could be. I haven't really planned out the spider levels yet, but that shouldn't really matter because whatever we decide to do there shouldn't affect anything else on this side. The spider levels just sit on top of the core system rather than all being intertwined. This is pretty much an evolution of the architecture in the prototype. The main difference is that now I've abstracted away the common functionality of each level too. Whereas before, in this version, we just didn't really go any deeper than just the scene level with our generalizations. Also, this version just hasn't really been thought out as much. There isn't a whole lot of detail in the design, but that's fine, it was a prototype, and hopefully our new design learns from the shortcomings of the old one and should be better. There's been a bunch of times where I've had to weigh the pros and cons of different approaches. So for example, the UI manager needs to be sent the level number so that it can display it on the screen. The approach I chose was to have the phobia scene manager have a reference to the UI manager instance in the scene so that it can call its update info method directly. The alternative was to basically go without this connection and have the UI manager continuously pull those variables from the phobia scene manager itself every update. I didn't really like this, as the UI manager would have no idea when the level number actually changes, so it has to be checking its value every single frame, where it will only actually change every few minutes. It just seemed more elegant for phobia scene manager to send this data over to the UI when it actually changes, rather than just all the time. That's pretty much the gist of it. If there's any bits that I've glossed over or clarifications that I haven't made, feel free to leave a comment and I'll try and go into some more detail. This design probably has a few mistakes in it. It definitely isn't perfect. I could keep working for another few weeks on it and it still wouldn't be perfect. Eventually you just have to draw the line and say, good enough, let's get started. Hopefully we'll catch any mistakes early enough for them not to be a big problem so that we can just correct our design as we go along. That's pretty much it today. Next episode we will finally be creating our Unity project and starting to build the core components of the system. I'm going to start uploading these dev diaries on Fridays rather than Thursdays. It just makes more sense to do the upload at the end of my working week to kind of give you the week's update. The planned schedule is to build the foundations of the system over the next week or two, and then after that maybe do a level or two a week. Whether or not it will actually end up like that, we'll just have to find out together. Stay tuned guys, and I'll see you in the next one.